Hello guys, I hope you have a great time watching the first part of my Leibniz through derivation. And in the next part of this video, I'm gonna use the fundamental theorem of calculus to evaluate on of the integral giant we got right here. So you see we have three integral giant, right? But two of them, we will need the fundamental theorem of calculus to evaluate them. So what are they? So the first one, let me call them I1. This the first integral giant. We need to calculate this guy. A alpha plus delta A alpha. I'm just gonna copy it. Okay. Fx delta plus delta alpha dx. The second integral theorem. The second giant is this guy. So you have b alpha plus delta b fx alpha plus delta alpha dx. Okay, so we need to calculate these two using the fundamental theorem of calculus. Now, what is the fundamental theorem of calculus? If you recall, say we have a graph, okay? This is fx, this is x, right? Let's say the graphs look like something like this. Okay, so let's say you have 2 points. This is, I call this point U, this is point V. So with point U, you're gonna have f of U. Point V, you're gonna have, let me see, f of V. Okay, so the fundamental, and I'm gonna collect 2 dot right here, and you're gonna have the line. Okay, so the fundamental theorem of calculus say that you can always find a line that tangent to the graph and parallel with the red line. Okay, so you're gonna find a line that tangent to the graph and parallel with the red line. I mean, you can always tangent to a live graph and parallel with the red line. What type of line is tangent to the graph? Is the derivative, right? So it means, in a nutshell, let me draw it in blue. Yeah, so this is calling it point C, right? So what you find is blue line parallel with red line, right? Well, this is, I'm missing the white, sorry Americans, there's no red, white, blue, it's just blue and red today. But I will hope to find a white color next time. So get back to the point. The fundamental theorem of calculus say that if you have a line connecting 2 point graph, you can always find a tangent line that parallel to it. Okay, so, and in this case, the tangent line is the blue line. Okay, so you have the blue line parallel with the red line. So you have what? You have the slope of the blue line equal the slope of the red line, right? So you have what? The slope of the blue line is f prime c. The slope of the red line would be fv minus fu over v minus u. Okay, so here we are. This is the fundamental theorem of calculus. Now, let me give you some recall of integral. So if you recall from a definition of integral, let me write definition of integral, right? You have, let's say you have a function fx, okay, and if you take the derivative of the function, you got small fx. So you recall the integral of a to b fx dx b f a minus f b. Okay, cool. Now I'm gonna use the fundamental theorem of calculus, but I'm gonna write it in terms of big F. Okay, I'm not gonna write it in terms of small f anymore. I'm gonna write it in terms of big F. So you have what? You have f prime of c equal f u minus f v over v. Yes, I mean it's fine, but I'm gonna stick to the notation right here. I'm gonna pick v, and this is u minus u. Okay, so f prime of c is nothing but f prime of c, f of c, right? Why? Because you have f prime of x equal fx. So you have f prime at point c equal fc, right? So fc equal to fv minus fu is nothing but, oh, this is too close. Let me move it out a little bit down. fc equal, this is integral of u to v fv, oh no, not fv, my apology, fx dx over v minus u, right? So you have what? You have an I would say a more update version, a different type version, a different type of dishes. No, not a different type, a variant. Oh my god, this is COVID-19 time. This is a perfect time to use that word. Okay, you have a variant of the fundamental theorem of calculus, and that variants are fc times v minus u equal integral of u v fx dx. Okay, this is the variant. Okay, now I'm gonna go ahead and apply this variant, this formula we just have, to the big 2. Okay, so apply, let me write, apply the variant to I1 and I2. So what do you have? Let me write I1 equal to integral of, let me scroll up. Okay, a alpha plus delta a fx alpha plus delta alpha dx. What is it equal to? It will equal to, since here you see here the alpha is a variable, so it will be equal to f of c alpha plus delta alpha, times v minus u. What is v? V is a alpha in this case plus delta a. The upper bound right here we have, this is v, okay, minus a alpha, right? And what is a alpha? A alpha is our lower bound, right? Okay, so I1 would be equal to f of c alpha plus delta alpha times delta a, right? Awesome. Okay, cool. So similarly, you have I2 equal B alpha plus delta B f x alpha plus delta alpha dx. What would be it will equal to f, instead of calling C, I will call it D, okay? D of alpha plus delta alpha delta B. Okay, understand? This is just, let me use it, I'm gonna use it in red. So this is our y1, this is our y2. Okay, cool. Now, so in the next part of the video, I'm gonna apply the result into the limit, and we should arrive at a conclusion of what is the di over d alpha. Thank you everyone for your attention.